Hello and welcome to Banks and Markets. So this is Binam, and if you click finance and scroll down, you'll see the section called bonds, and in this section I'm going to talk about bonds, and this is a continuous series in which I am discussing bond fundamentals and mainly the pricing aspect of the bonds, including bond price volatility. All right, so if you recall, I was talking about one example, how modified duration can be calculated, in which I was using the example from this slide. Now I would like to give another example on modified duration, in which you can also see the usefulness of the modified duration. What you will ultimately appreciate is the fact that the modified duration is a very important concept when the change in yield is small. It works really well, and generally speaking, the change in yield is not big. The basis point changes remains small, generally speaking. Therefore, the modified duration concept works really well. But when it is a big change in the yield, then the modified duration is not the appropriate solution. Therefore, we need to look for other measures such as the convexity. So now we want to appreciate these facts. So the example starts with this 25-year 6% bond selling at 70.3570. and the yield is 9%. 25 years 6%, 9% is the yield. So with that in mind, I have this information, 9%, therefore 4.5, because 4.5 is the half of the 9, isn't it? So E divided by 2. And then it says 6%, so 6% in terms of redemption value of 100 will be £6, and therefore the half of the £6 will be 3, and that's £3 here. Okay, now this is basically the present value of £1 in period 1, which is at 4.5%, therefore it's 0.5, and so on. So I can just double click and find it for all my cash flows for different periods. Remember, the last one, which is 50th period, is not 3 but 103, because the £100, the par value or the nominal value, will be returned. Okay, so that's what we have done. Now remember, we're talking about calculating duration and modified duration, and the formula for duration is here, which is this, and to calculate this particular to use this particular formula, you need these. So basically the price of the bond, the question has already given you in fact the price of the bond, which is 70.3570. Nonetheless, we can see if that is the correct price given the properties of the bond, which is 25-year, therefore 50 periods, and 6% semi-annual, therefore £3, and coupon 9%, and for the calculation purpose, therefore 4.5. Okay, so we've understood this. Now what we need to do is find out the present value of cash flows, which is going to be 3 times this discount factor, and double click, and what we are interested is the price of the bond, and therefore the summation of this is the price of the bond, which is therefore summation all of that. So we get this 70.35699, which is what we saw earlier on in the question, didn't we? So that's correct. Now we found the price of the bond, which is this 70.3570 price of the bond. Okay, 70.3570, or this particular formula. Now what we need after this is, if you see in this formula, that's the price of the present value of all the cash flow times T. So over here we need to present value times T, and that's going to give us this times T, which is 1, and so on for all remaining coupons. Now we also need to find out the total of these, which is going to be all of that. So therefore 1561.269. What is this? This is the item here in this formula here, 15.6. okay, so you know this. Now how do you find duration? Duration is basically equal 15.61 divided by this, so that is number of years, 22.19068. But this is based on semi-annual, so what do you need to do to find out the annualized duration? This needs to be divided by 2, so that's annualized duration, and this is the answer. So this is in blue, that's what we found. Now what about modified duration? Modified duration, we know from the formula, is duration divided by 1 plus the yield, which is nominal yield, which is 9%, divided by the coupon payment frequency, which is 2, and therefore you get this number here, which is 10.61755. This is basically the modified duration. Now can I tell you something? We applied the lengthy way and found duration and modified duration. In fact, the same thing you can do by asking Excel what is modified duration, what is duration, and that's something I have shown here. Okay, so if you just click and ask for duration and then apply this, because this is the particular bond we're talking about, settlement, maturity, coupon rate, yield, coupon payment frequency, and day count convention, you get 11.0953. You see exactly the same thing. So you do not need to waste your time doing all these lengthy calculations, just this. But for understanding purpose, it's always good that you know how and what Excel does behind the scene to get this computation. Similarly, modified duration, if you go here, instead of duration, now you type in M duration. Okay, and M duration, again, settlement, maturity, and then coupon, settlement, maturity, coupon rate, and then yield, which is 9%, and then payment frequency, and this. So exactly same as in duration, just the formula is M duration instead of duration, and you get this 10.6175. That's what you calculated here, 10.6175. Okay, we now know the modified duration and duration. We've calculated them. Now the question is saying a small change in yield, say 9% to 9.10%. What is the approximate percentage change in price? Okay, for this bond, which is 25-year 6% bond. So what you can do now is see in the Excel file what has happened for this bond, which is 25%, 25 years, 6%, this is 70.3570, isn't it? So that's what we are talking about. What has happened to this particular bond when the yield changes from 9 to 9.1? So when yield changes from 9 to 9.1, here the price of the bond is now this, which is yellow highlighted here. So 25 years, 70.3570, from here you get to this point, which is 1.05. so let me highlight these as well in yellow. Okay, so we see that from when moving, the yield goes up from 9 to 9.1, then the percentage price change in bond is minus 1.05%. remember this number, minus 1.05%. What we want to see now is what happens when it goes, the yield goes down from 9 to 8.9. Okay, so again in the same example, from 9.8.9, which is here, then it is this one, 1.07%. okay, so what we found here is when yield goes up, then the percentage price decrease is minus 1.05. so that's something we want to mention. Okay, so when yield goes up, then we recorded the change is minus 1.05. okay, minus 1.05. when it goes down, 1.07. minus 1.05 and 1.07, minus 1.05%. In fact, it's good. Let me copy that from there. Okay, so this was here. I take this one, and when yield goes down, then this is this number here, 1.07. So we found them. Okay, so let me increase the decimal places a little bit, and we've got something like this. Now what I would like to do now is to see what happens when we apply the modified duration concept. Okay, because earlier on you were able to see this formula here. Okay, this particular formula. Okay, so we'll use this formula now and see what happens in terms of percentage price change. So basically what we need to do is equal modified duration, which is 11.09, isn't it? But then in the formula there is minus, so minus 11 point this, and then times what is the percentage change. Yield goes up by what? If you read the question, it says from 9 to 9.1, isn't it? Here 9 to 9.1, so that's from 9 to 9.1. You're talking about 0.10%. okay, or you can put it in the basis point, whatever. This is what you get. So hit enter and you get this minus F5, which is the modified duration, which is 10.61. sorry, it is not F5 but G4. okay, so G4 is the number to take. Then you get this. Can you see we applied modified duration here, which is this. Now we're comparing it with when the yield goes up. You do the same, exactly same, when the yield goes down. When it goes down, it should be minus, isn't it? That's it. And it is 0.10618. So if you change them into percentage term, then comparison is easier. Okay, can you see this? That when we applied the modified duration, we got these percentage price change, but actual change are them, but they're very close. 1.0618 minus 1.0527, 1.071, 1.0618. so let us see 10.61 minus 0.1%, and therefore, so this means modified duration has worked. Modified duration is able to give us similar price change. Similar means as in actual. Okay, and this has happened when the yield change is small. Yeah, the yield change was only from 9 to 9.10, or from 9 to, remember, 8.9. okay, so this happened. But what happens if yield increases by 200 basis points? Okay, so then in that case it is the modified duration, which is this. Okay, but we need to put it in minus, so minus modified duration, which is this, and then 200 basis point. Yeah, so that's what the question is asking you, 200 basis points. So 0.2%, when you do this, you get 0.02124, which in terms of percentage is minus, let me see what we need to do, not 0.2%, isn't it? The basis point is what we are talking here. So basically what was it, 2, so it will be let me do it again. Okay, so the modified duration is this, so equal minus 10.61 this number here, and then times your plus not 2, isn't it? Yeah, that's 200 basis point. So then you get minus 21.24. Minus 21.24 is what you get here. Okay, now minus 21.24 is given by modified duration. What is it in actual? So to find out the actual, you need to see the question. It is telling you increases by 200 basis point. So in this example, for 200 basis point increment is here from 9 to 11, yeah, and then you need to find out the percentage change. So 9 to 11 percentage change is minus 18.03. Can you see it's minus 18.03, whereas the one that we calculated using is minus 21.24. So let me take this one here. So there's a big difference between these two. So therefore modified duration is not able to give us similar price change as in actual. Okay, so to resort to this issue, what we need to do is think of some other measure, and that other measure is called convexity, and this is about the convexity I will be talking in my next video. Thank you very much for listening. Thank you.